Hello, fellow Gophers, Go developers. If you are also a Schwab investor and you want to check out a package that I just made, well, not just made, been working on it for about 3 years now, just released version 0.9.0, which is basically going to be until version 1, one of the last stable releases. It has pretty much everything that I would personally want out of a wrapper, which is why I'm making this video, is that it's kind of like finally almost done. But yeah, if you want a wrapper for trading and getting data from Schwab, check it out. It's on GitHub, go-schwab/trader. I'm making this video to kind of just run through it, show kind of the basics of how it works, and how to access the data in this library. So, first things first. If you go to the website and scroll down to the quick start page, it's super simple. Follow these instructions, make an app, get your app details, make a .env, put the app details in the .env, and then you need to run this command to generate your SSL certificates for the secure TLS OAuth exchange with Schwab servers to get your bearer token. Then you run a go-get to get the version 0.9.0 of the library, and you're good. This should look fairly straightforward for anyone else, for anyone who has previously used an authorized library. But from there, all you need to do is you need to call the initiate function. What does the initiate function do? I wanted to quickly run through what this library is and what it does before I run through the various data and trading functions. So if you want to skip to just trading and accessing data, then there will be timestamps. But the way that the library works is you call the initiate function. The initiate function returns a pointer to an agent. An agent is a super simple function. Super simple function. All it does is, I just realized I need to remove the pointer because it's actually redundant now. But all it does, all it is a pointer itself to an authorized client. What is an authorized client? Well, it's part of the internal utilities package that we have created. It lives at github.com/go-schwab/utils, and at the /OAuth directory of that package, you will find this code. The authorized client type is simply a pointer to an http.client and a token of a pointer to an OAuth2.token type. An OAuth2.token type is kind of what it sounds like. It's a token struct with the access token, the type of the token, which for Schwab is a bearer token, the refresh token, which is used to refresh the bearer token, the expiry of the access token, and expires in. Expires in and expiry do similar things, as you can obviously tell. But both are used to tell when the refresh token is needed, and it automatically refreshes. That's the beauty of the OAuth library. So this client is used in the handler function to handle all of the various requests that are passed to it through the data functions, and super straightforward. If you want to view the code for yourself, you can read it in the library. One of the neat things is that you can we support multiple end files, so you can put multiple .env files in your directory and it'll work the same for multiple accounts, obviously. But anyways, that all being said, what I want to go through now is the data functions. So the data functions are really straightforward. So once you have initiated, you are going to you want to obviously get some data. So the first function that I want to run through is getQuote. GetQuote accepts a symbol. For this example, we used Apple. And when you call it, ignore the time. It's for some reason it's getting thrown off. I have no clue why. That's not the actual time it takes. But for Apple, here, just to show you, it's very, very fucking quick. So the real-time quote, the struct details are all, I'm not going to run through all the structs because it's taking way too much fucking time. The struct details are all in the docs. If you want to read the docs, they are all here. So if you want to get quote is here, price history is here. All of it's described in far more detail there. So if you want far more detail, go to the documentation, obviously. but gives you a bunch of different data points and parameters. The get price history function, again, fairly straightforward, gets the price history. It accepts a number of parameters. The first is the symbol. Second is the period. Period is the overall scope of what you want to request. This can be month, it can be week, or I don't think it can be week actually. I think it can only be month, and then year. And then that specifies the amount of months or years. Frequency is daily, weekly. I think it could be out. I actually might have been mistaken. Actually, I think you can get daily and weekly periods, but then that only works with hourly and minute frequencies. But again, check the documentation. All of this is described in more detail in the documentation. Anyways, so for this example, we're getting 1 month's worth of data every day of that month. And as you can see, it returns it, and the data that it returns is of the type candle. And that type just has time, volume, open, close, high, low, and it acts similar to a pandas data frame in the way that it is obviously set up. I want to create some. This is set for down the line, but I want to create a library that essentially does this. It is essentially a pandas data frame-esque. I know there's some in Go, but there's not many. I found one library that's written in assembly that I might want to implement. But regardless, right now it returns this, and you have to do your own math. I want to do some custom filtering eventually. Again, I digress. Next is a simple instrument search. A simple instrument search is for if you just want super, super simple information on an asset. So like, as you can see here, QSIP simple description exchange asset type, super simple. Fundamental instrument, search instrument fundamental is for when you want more information, for when you want like literally all of the information that it could possibly give you. EPS information, profit, operating margin, revenue, ROI, ROE, ROA, book value, beta, EPS, etc. All of that is in fundamental instrument, search instrument fundamental rather. Get movers is the last data function. It accepts the ticker. Not the ticker, the exchange that you want to search, and then down or up and percent or value, again, filtering. And it returns this. Again, the struct details are in the docs. So that's data. Next is trading. Trading, I don't have a super great example for. Actually, I do have, it's in the test, so I'll show that in a sec, but from the docs, what you need to do first is get account numbers. Your account numbers are, it's a struct with the account number, with the account number, what is even happening? Sorry, my computer's like really slow because of Loom. So our account number struct contains account number and hash value. It contains an array of these account number and hash values. If you have multiple accounts at Schwab, you'll have multiple results. If you just have one, then you'll just have one result, obviously. And so for the example, I just used, because my account only has one, I just used one account. So you get the first element of the array, and then you index its hash value. So once you get the hash value, you pass that into submit single leg order. Submit single leg order is a super simple function. All it does is it marshals, so you pass it the hash value, and then the create single leg order function. Now the create single leg order function, you pass it technically a pointer to a single leg order, but you're supposed to use the create single leg order function. The create single leg order function, what it does is it accepts an unknown number of options. These options are all here, and they're also described in the documentation. Order type, session, duration, strategy, instruction, quantity, and instrument. They're all functions, and they accept the various types that are required by Schwab, right? There are, though, defaults, same defaults that Schwab insists upon, right? Order type, session, duration, and strategy. You can change these, but if you leave them blank, these are your automatic defaults. So if you just want to make a single day normal market order, right, and you just want to specify your instruction, your quantity, and your instrument, you can do that, and you can exclude these. The defaults are specified in the struct. So, anyways, point being, you use the create single leg order function to pass your instructions, your options, and those options are then marshaled into these strings. These strings are then submitted off to Schwab as trades. Pretty straightforward. But let's say that I wanted to buy Apple. I wanted to buy 1 share of Apple. So I would, if I wanted all of these defaults, and again, if I didn't want these defaults, I would specify whatever I wanted in this. And again, all of these are specified in the documentation as well as in Schwab's developer documentation. But if I wanted to buy 1 share of Apple, then I would set error equal to agent.submit single leg order, pass in our encrypted account value, as well as a single leg order, which we create single leg order with the instruction buy quantity 1, because Schwab does accept floating point values for this, and our instrument of type simple order instrument. Symbol is Apple, asset type equity. Very, very simple. Once you get that back, you'll check the error, and you're off to the races. Your order has been submitted. If there's an error, or if your order wasn't submitted properly, there will be an error. If your order was submitted properly, there will be no error. So what I recommend doing is making this separate, right? Because theoretically you want to be logging your orders. So theoretically you want to be creating this as a separate. Struct or object, and then passing it in, and then logging it after checking for an error. So all of these functions work, but I just haven't gotten around to creating documentation for them. And that's basically it. If you want to contribute, all of the development work happens on the dev branch, so you can just create a fork and submit to the dev branch. We have various issues open that I'm accepting contributions on, so if you want to help out, more than welcome to. If you just want to use it to create some cool stuff, you can also do that. This isn't part of the video, obviously, but I created, this isn't even going to be, no, there we go. So I created a terminal trading app that I then broke, which is kind of classic. But I was able to implement all of these, I was able to implement successfully all of these indicators using just the data that was provided. And this is obvious, but it was super, super easy to create this. It was super, super easy. And so I would highly recommend just going in and experimenting. Because, just to go and quickly show you, as you can see, it's super easily indexable. All of the structs are super, super easily indexable. So, SMA, obviously, is given to you in the struct. So you can use SMA, EMA, whatever indicators that you want, you can create. Anyways, makes it very, very easy to do whatever you want to do as a data scientist or a trader. So that's the package. That's everything. If you want to use it, go ahead. If you don't want to use it, don't. We have a Discord. I'll put that in the description. I just made it. There's no one in it, so if you don't want to join that, don't. But I would like to see you on the issues. If you run into anything, let me know. And if you have any questions, just drop them. I'd be happy to answer them. Yeah. Peace.